When we're describing how much uncertainty we have in our data, there are three terms that are very useful to know: accuracy, trueness, and precision. They all describe something slightly different. Accuracy is how correct is a single measurement. How close is the measurement to a true value? If you took the difference between a measurement and the true value, that would be a measure of accuracy, and we would call that difference the experimental error in that piece of data. Now, very often we don't have a single piece of data. We've got a whole set of it, and we want to describe how good the whole set is. So instead of looking at the difference between the measurement and the true value, we look at the difference between the average of all the measurements and the true value. That's called the trueness. Finally, we can look at whether or not we're getting the same measurement every time we repeat it. If all of your measurements are very close together and they're all clustered around the average, you say you have good precision. So precision is a measure of how much scatter you've got in your data set. Now, we can look at the differences between these three different terms by looking at these bullseyes down here. Now imagine that the center of the bullseye is the true value. That's where you want to hit. And each of the little black dots is where you fired an arrow. That represents a measurement. Now this first target here is ideal because the true value is in the center and all of your measurements are clustered very closely around it. You're getting the correct value every time you make a measurement. So you've got good accuracy because each one of your measurements is close to the true value, the center. You've got good precision because there's not a lot of scatter in the data. It's not all scattered everywhere randomly. And you also have, if you look at where the average measurement would be, it would be the center of the pattern here where I've got the laser pointer. That's close to the true value too. So you say you've got good trueness. So you have good accuracy for each individual data point. You have good precision because you have got not a lot of scatter. And you've got good trueness because the average is close to the center of the pattern. Let's look at the second target. It's a different story. Here's where my true value is. Here's where my average measurement is. Now, if I look at the accuracy, that refers to each individual measurement, and none of them are close to the true value. So I would say about this data set that I have poor accuracy in all of my points. What about my precision? Well, all of my measurements are pretty close to the mean value, and that is there's not a lot of scatter in the data, so I have good precision. What about my trueness? Well, the average value, where I have the laser pointer, is far away from where the true value is here, so my trueness is poor. So I'd say, well, I have good precision, but I have poor accuracy because I have poor trueness. And we have another story here with this third target. Notice that the measurements are scattered around the mean, and the mean would be the center of this pattern, and it is just about right on the bullseye where the true value is. So I would say about this data set that since the average is close to the true value here, the center of the bullseye, I have good trueness. How about my precision? Well, I've got a lot of scatter around the average value, so my precision is relatively poor. How about my accuracy? If I look at the individual points, they are far from the average value. None of these is close to the average value here, so I could say all of my points have poor accuracy. So do you see the difference between trueness and precision and accuracy? Trueness and precision refer to the entire data set, whereas accuracy, you're just looking at one point at a time. Now with the final target, we've got the worst case. It looks to me like my measurements are scattered around The mean, the center of the pattern, would be right about there, and it's pretty far away from the true value where I want it to be in the bullseye. So I'm going to say I have poor accuracy because each of the points individually is far away from the true value. I'm going to say I have poor trueness as well. Here's where the average would be. And it is fairly far away from the true value, the center of the pattern. And I'm also going to say I have poor precision because there's quite a lot of scatter compared to the other targets anyway around the mean. Now, before we leave this slide, I want to point out that what I'm using here, this accuracy, trueness, and precision, are a set of definitions that are made by something called ISO, the International Standards Organization. And this is what engineers and scientists use. Now, a lot of textbooks don't use the ISO, and that is they don't talk about trueness at all. They only look at accuracy, and they use accuracy as though it's the same thing as trueness. And it isn't quite. Accuracy refers to each individual measurement, where trueness refers to the average. And they're kind of fuzzy about how to distinguish these two. So watch out when you're reading a book that doesn't talk at all about trueness. They are probably just lumping these two things together, which it turns out isn't very helpful.